Okay, we're back. So, there's a lot of equations on this board, but trust me that it's not that bad. We're just going to work through it real slowly. So what we start with is the cyclical component of output equals alpha times YCT minus 1, or what the cyclical component of output was last period, plus that demand shock ET. Now, what we assume is that the economy is stable, where if this relationship exists in period t, it also exists in equation 2 for YCT minus 1. So all we're saying now is YCT minus 1 again equals alpha, but now we go back to period t minus 2 because it's the preceding period. And then we have plus the demand shock from period t minus 1. So what we have here is the cyclical component of output in period t. And here is the cyclical component of output in period t minus 1. So the equations are identical, except that we have the time script t here and t minus 1 there. What we have now is that t minus 1 is now equal to what the cyclical component of output was in period t minus 2, plus the demand shock in t minus 1. So we have this relationship in period t, and we also have the relationship existing in period t minus 1. So now what we do is we substitute this equation into equation 1. So what we do is take this expression right here and we substitute it into YCT minus 1 right here. So what we have now is YCT equals alpha, which is that variable, times YCT minus 1, but what we do is substitute this expression into here, and in brackets this is YCT minus 2, which is identical to what we have here, then plus the demand shock from period t, which is ET. So let me now multiply this alpha through. So what I do is I get alpha times alpha, which is alpha squared, times YCT minus 2, and then this alpha times ET minus 1, which is alpha times ET minus 1 right here. I'm just multiplying the alpha through. And then what I have is plus ET. So again, just to repeat, is I have the two equations, equations 1 and equation 2. I substitute in what YCT minus 1 is into right here. Okay? And that's what I get right here. Then I just multiply the alpha through, and I get alpha squared YCT minus 2 plus alpha times ET, which is alpha ET minus 1, which is alpha times ET minus 1 right here, plus ET. I now rearrange. I just want to put this in order of time. So I still have the alpha squared times YCT minus 2, and I'm just rearranging this. I'm putting ET first, and then alpha times ET minus 1 second. Okay, now I'm going to do the exact same thing again. For equation 4, I have YCT minus 2. I'm going back 2 periods, and that equals alpha times YCT minus 3 plus ET minus 2. So I'm just backdating these 2 periods. I started in period t here, t minus 1 here, and then t minus 2 here. Okay? So I now substitute 4, which is the YCT minus 2 equation, into YCT again. So I'm going to substitute this stuff right into here. Okay? So I do that substitution, and you can see on the board I then have alpha squared, because I'm now substituting into this equation alpha squared what YCT minus 3 is. So I'm taking this expression and putting it in this bracket, alpha YCT minus 3 plus ET minus 2, but then I still have this part, which is ET plus alpha ET minus 1. So if I just multiply this alpha squared through and rearrange, what I have is YCT equals alpha cubed YCT minus 3 plus the demand shock in period t plus the demand shock in period t minus 1 multiplied by alpha, and then I have ET minus 2, 2 periods back, multiplied by alpha squared. So again, I do not want you to get upset with the algebra. But what I want you to see is to redo the algebra in your notes, just to understand the substitution method we have going on. Then, on the next film, I'm going to start with this equation, and then I'm going to generalize it. Okay, so I'm going to put it up on top, and then we'll talk about it. So, we'll see you in a little bit.